The one thing I would say most recently is that we made the decision to go into the smart grid AMI space, and we had quite a considerable effort to actually develop the software necessary to feed this ERP system what it needs.
Excellent. Clemens? Yeah.
I might need really 2 minutes, but I promise to keep that.
Please take your 2 minutes, that's fine.
Just to set the context, is the worldwide industry is accounting for around 30% of the global energy consumption, and is therefore for a clear reason in the focus of laws and regulations in order to reduce carbon footprint, energy consumption, etc. We at Schneider Electric, we are helping those customers reducing their energy consumption by eliminating the technology barriers and information barriers between power, automation, infrastructure, building management, based on our EcoStructure initiative and architecture. And this really enables our customers to understand their energy consumption pattern in clear relation to towards their production pattern. And this really helps them to optimize, to reduce, and also to comply with the local laws and regulations. And this is the business we do, energy management. And this is the main initiative, EcoStructure architecture.
One thing that's recently happened, Joe Hogan just joined as our CEO from GE, and as we've stepped back and taken a look at our markets, ABB is comprised of 5 divisions, and there's about 30 business units there. Is we've taken a critical look at the market from your perspective in the room. And so we've started aligning around certain industry segments: smart grid, solar, wind, water, rail, data centers, energy efficiency, and developing the value propositions around each one of those ISIs, what we call industry segment initiatives. And we've also recently added one called e-mobility. So it's really changed the face of how we operate internally as one ABB, and also how we as a company relate to our customers.
How we really pass real-time information upwards. What we are doing is we are providing seamlessly architecture from the device level up to the enterprise level, based on our plant structure architecture, which seamlessly fits into the EcoStructure architecture. And what we are doing is really on a device level, starting that between the power infrastructure and the automation infrastructure, we are sharing the information real time. And this enables you as an end user really to understand what's going on in your production and how your energy consumption is relating to this one. So the tool is called Production Energy Optimization Tool. We have presented it yesterday here, and this gives you real-time information and to understand what's going
on. One of the differences, I'd say with this merger over the past was in general, we would normally, take the acquired company, move them over to the Dow architecture, and and go from there. We're in the process of upgrading our Dow architecture to a new system. So we made the decision, again against our culture, to allow the Roman Haas businesses to continue to operate on their current platform, and then merging the information at a higher level that enables us to learn merged businesses. So that was probably the biggest challenge for us right off the bat, was to merge those 2 data sets at a higher level to still enable us to get the details that we needed to run those businesses. And culturally, right, for us, it's to do things differently than we have in the past, which we've been very successful at. But to see the need to do things differently and then to follow through with that probably is our biggest challenge.
Thank you, Don. As Don said, we have a very good presence from Dow executives in the audience. So I would encourage, I'm sure a lot of you folks know Eric Kosman. He's here someplace, and other folks, there he is. He could certainly have, spend more time, talking with you what sort of challenges they face. Yes. We have a question over here. Yeah.
Yes, a couple of things. First of all, when we went out to implement the integration. We went out and we engaged our plant leaders at every level. So, I went and personally had meetings where we brought, over 100 people together around the world, but we did it geographically. And the first thing that we did was to establish some real clear, basic, simple priorities. I personally have a deep passion for safety performance, for our EH&S improvement. And so at the beginning of the system, I had 10 to 12 key tenets, key things that I believe are very important to have good, sustainable operations, things that lead to improvement in safety and environmental performance. And so I had a face-to-face discussion with every leader of every plant around those expectations, and we focused on those initially. And we built those into our IMS system so that there are things like, not having any open-ended connections in your facility, right? That there's no open valves, there's no open fittings, everything has a plug or a cap. And so I took a key 12 tenets. We pushed those out first because, as you know, to really get true integration on EH&S systems, can take up to 2 or 3 years, but we didn't want to wait that long to get improvement. So probably the key was building into our integration, a key 10 or 12 things that I expected each of those plants to do, explaining that very clearly to the production leaders and then into the plants as I visited those. And those key things had a tremendous effect on our ability to reduce spills, environmental incidents, and safety injuries. So.
It's if you look at today's manufacturing environment, ease of use is key. Information transparency, interconnectivity. So the system has to be modular, scalable, in order really to adapt it to the environment you find in a given plant. You don't want to rip off everything and then renew, so that you can scale up with your requirements. Process modules built in order to facilitate for less skilled people the operation and still have some continuous improvement processes. Just as a few examples.
When you look at companies like Schneider, companies like ABB, we talk power and automation and how you bridge the two and how you integrate the two. For us, it's also understanding from the customer's perspective that you're really interested in reliability, efficiency, on-time delivery, and the challenge for us is how we focus on that and deliver what the solution you want from those regards, from the soft side of things.
On the product level, we talk about innovation for simplicity. This is for us key to sell, particularly also in emerging countries where you have less skilled people. And how could I prove it? My 15-year-old son has commissioned a drive on its own in my garage during Christmas. It's children easy. It hasn't been 10 years ago like that, or 15 years.
We're doing the layer of data that connects into the plant. There's 3 levels. The levels first is on the interfaces. What we have found particularly with these metering projects is that they're just too large to rely on manual configuration. If you're dealing with 6 million meters and 30 points per meter, that's a very large database. So interfaces now have to start up automatically. They have to be able to reconcile themselves with the plant systems automatically, including the metastructures that are now housed in those systems. At the middle layer where you're actually storing the data, the larger your system, the easier it is for the people. So that has to scale up, actually to millions of points. And then at the visualization layer, I still think we can thank Microsoft for teaching 800 million people how to use Office. So driving the data back into Office where they actually know how to use the system, and then automating as many of the other IT procedures as you can. The virus for the virus updates, for the security, the normal updates, and then finally for certain classes of systems and critical, we actually monitor them from a NOC. Okay. So we've all done this specifically to make the systems easier for the user. Okay.
There's been a real step change in terms of usability, in terms of user interfaces. I mean, and a lot of the investment that's going into software companies today is making it easier from a user interface. You know, today's generation of new engineers has a certain level of expectation in terms of usability. And not only the suppliers, but also the users are adapting to that. So certainly in oil and gas, at the plant level, we've made significant investments and are basically creating interfaces that are consistent with the way that the industry is moving all across other industries.
I think certainly, ease of using the data has improved the systems that we have. One of the things that we're interested in, is being able to monitor things globally across our different by technology around the world, and that certainly has gotten easier for us to have our expertise now sitting anywhere in the world that can help troubleshoot, problems in plants in any country that we operate, and that the ease of doing that has improved, and certainly, we'll want it where they can do it from their cell phone in their, in their living room before it's all over with, right? But, it's certainly gotten better over the last few years.
The smart grid has really become a huge height. We're doing a lot. We're putting $13 billion worth of new meters in California. That basically the main advantage to the users is that they can disconnect you more easily. It is the right thing to do, but we haven't really looked at what we're going to do with those meters, and as it was pointed out, it's a lot more than meters. It's how we operate in a digital world. And we're starting to see now emerge, after years, we're starting to see emerge a few people. One of them will be speaking here, I believe, is speaking here on industrial demand response. But we're seeing a few places where people are taking advantage of this high interaction with utilities. I must say, though, these are different cultures. When you look at, put some numbers in David's presentation, if you shut down one small refinery, a 250,000 barrel a day refinery in California or in the western United States, that means you're going to add 4 million electric cars. It means you're going to take our power from 32 gigawatts up over 60%. We're going to have to send it to areas that don't have transmission lines so we can charge these things. And by the way, we can't use oil. We can only use gas in California. So tremendous dislocation by the whole movement, but it's probably good dislocation.
What we are offering is clear migration programs for each of our controlled families, program converters to make it easy, and offering also in terms of network connectivity all the useful standards which are there in order to really make it easy to upgrade the installation, and without losing the value of what is still there and is still working well. So migration programs, migration support, specific teams on that, really to help the customer to do it.
I think, and that's a given. There's some external factors that also come into play. The interoperability, IEC 61850, where as customers you have more of a common platform. So as systems age, at least there is not so many standalone type systems that we have to deal with out there, and you have to deal with as a customer. The other piece of that is continuous improvement, continuous training, and continuous skills upgrade. And as we've seen the emergence of like the iPhone, the harmonization of user interfaces across the board, I think that eases the pain in the future.